Hello and welcome to Spring 3.0 training. We are going to see Chapter 6B, which covers the JMS integration of Spring. So let's quickly run through the content of it. The content involves the little bit of basics of JMS first, because before we jump on to integration part we need to understand what is JMS itself. So we'll see what is JMS, we'll see slight differences between JMS and email, then we'll look through the JMS applications and its different components that creates the complete JMS application. We'll also look through some of the things like JMS provider, messaging model. We also will dig into the API programming model. Then we'll see the messaging consumption types, and then we'll jump onto the Spring JMS integration, how JMS integrates with the Spring and how it makes the JMS code writing easier. And we'll see some code samples, and then we'll look into the details of the course content. What are the different message types, what are the miscellaneous JMS features provided inside Spring, how we include JNDIs, how we talk to JNDIs, how we can use SOAP inside a JMS messaging model, and miscellaneous topics. Right, so before we jump on to what is JMS, we first need to understand the messaging, the message itself. So JMS is Java Messaging Service, but what is message and what is messaging? If you go by the definition, message is nothing but a piece of data, the information. So message is what? A piece of information that is being exchanged between two parties. So a message is described in various ways by different specification. However, it is nothing but entity of communication, a piece of information, a piece of communication. It is bytes of data that is meaningful between applications which use it. So messages are used to transfer information from one application to other ones which may or may not run in the same platform. And similarly, a system which is used to transfer message from one system to another is called messaging. So message is a communication between system components or different application in a distributed environment, which is loosely coupled, unlike its peer like TCP sockets, core bar and Amara, which are tightly coupled. So, and what are the advantage of messaging? The advantage of Java messaging includes ability to integrate different platforms. It doesn't matter who is sending the message or who is receiving the message. The different platforms can talk to each other, and increases scalability. You can increase the system and the clients who are consuming and producing the messages as much as you want, and the reliability of message delivery. We have quite a lot of ways in which we communicate, right from the instance messengers to the stock tickers to the SATCOM navigations to the mobile based messaging to the old age messaging systems that we have seen before. So they are all part of messaging. We now understand what is message. It is just a piece of data being transferred from one system to another, and it can be between humans as well. But yeah, it is mainly, when we are talking about the messaging in terms of JMS, it will be mainly between systems rather than between human beings like email. Unlike email, the JMS is slightly different. So we'll see that we'll compare and contrast between the JMS and email in the later slides. Right, so let's quickly understand what is JMS. JMS is a Java message oriented middleware. It's a middleware, it's a broker, it's an agent, which it's much like a post office and a postman. I am sending a mail post via post to a friend. So I am a client who is sending the message, and my friend is a client who is receiving the message. But we need to have a middleware who can take my mail and send it to my friend. So that is the message oriented middleware. So JMS is a Java message oriented middleware API for sending message between two or more clients. So Java is part of JEE, Java Enterprise Edition. And what is JMS? It's a specification, right, that describes the common way of Java programs to create, send, receive and read distributed enterprise messages, and it advocates the loosely coupled communication. It doesn't matter who is the sender and who is the receiver. The loosely coupled system, it doesn't care who is the sender and receiver. Asynchronous messaging means it doesn't matter whether the sender and receiver are present at the same time or not. They don't have to be those two systems who are sending and receiving, they don't need to be up at the same time. So that's the asynchronous messaging. And reliable delivery, it makes sure that message is guaranteed to be delivered once and only once. It won't message won't get lost, and it won't be delivered more than once. So that is the JMS promise. Let's quickly run on to the look at sample of JMS application pictorially. So we have a sender and we have a receiver. So what receiver and sender does is this part is sending a message. So we need a broker in between who can take my message, piece of information, pass it on to the network to the receiver. And then we have a second way of representing it. So we normally, what is this message oriented middleware? It's normally a MQ application. So this provider can be something like ActiveMQ or IBM MQ. We will see different message providers. So what a sender does is, sender can be the promise is that we are loosely coupled and it supports all type of platforms. So sender can be .NET application or a mainframe based application, and receiver can be Java or Spring based application, and this receiver can send that information back to the sender as well. So this is a two-way communication which is loosely coupled. There we can say it doesn't matter where the platforms are, it's a typical application. In an application you have a producer goes to the middleware, that is the MQ, and it sends the message to the queue, and receiver receives it. So this is a typical Java application which has three major parts: the message oriented middleware, the sender, and the receiver. And sender and receiver can become, this sender can become a receiver as well, and this receiver can send back a response. So sender sends a request and receiver can send back a response. So the sender and receiver are not fixed roles. Sender can be a receiver, receiver can also become a sender in a JMS application. Now before we move on to other parts of the presentation, let's quickly see the very basic confusion that we all have, that messaging, how the email differs from Java messaging. So Java Mail is an API for sending mails and with attachment and reading emails. It is mainly for human to human information exchange, whereas messaging service is capable of exchanging message between applications. Message between applications, two systems are communicating with each other. Ultimate recipient might be human itself. That's not the point. The point is that those messages are supposed to happen between two systems. Delivery can be duplicate or not guaranteed. Say for example, it's not a big deal to get multiple copies of an email. Say for example, if you lose a connection with an email server over POP, you might get same applications, same emails copy again. JMS is more like database. The message can be configured to be drained if and only if recipient systems read it. In other words, delivery can be guaranteed. Message guarantee is very important aspect. Why? It will be a major disaster if you get two copies of message saying remove $1,000 from my bank account or sell 50% of the share. It may not be a big problem if I get a mail twice, but if I get these messages twice, it may mean a business loss or it may mean a financial loss. So that's where the JMS comes in. The JMS promise, I won't give you duplicate and I'll guarantee the delivery of the message. An email is designed for the connectivity on the web between human beings. JMS has a bunch of different qualities of service. It is durability versus non-durability, queues versus topics, like point to point and publish subscriber. We'll see these details later on, and designed for very high performance messaging with low latency together with reliability to avoid duplicate and message loss. So there are quite a bit of differences between Java Mail and JMS, so you are not supposed to confuse between these two. Having said that, the only correlation between both technologies both are intended for transmissions of messages. The main difference between these two is their history and design criteria. In the very beginning, email was the first thing, and later on it was realized that email is not reliable enough for very extreme systems, and the design criteria has changed for messaging system. JMS is for sending messages between application component, and Java Mail API is for sending actual email. Let's move on to the JMS components. What the JMS components looks like. The JMS component are basically the provider itself, the middleware, message oriented middleware that implements JSS in addition to their administrative and control functionality, requires a full feature messaging product like IBM MQ or Active MQ. There are lots of other middleware as well, JMS provider as well. We'll see the details of those. It's a message broker. It's a broker in between. It's a like agent in between who takes the message and sends the message across. It's like a post office. It's like a postman and post office which takes your mail and which delivers it to the recipient. Then we have JMS clients, the one who is producing or receiving the message. Me and my friends are JMS clients. I am sending a mail, a postcard to my friend. So I and my friend is the JMS clients that produces or receives message. And if I am sending a mail, I am the JMS producer. If my friend is receiving the mail, he is JMS consumer. Producer and publishers are senders and they are clients, and consumer and subscribers are receivers, and there are two types of JMS clients. So there are in fact 4 types of JMS client. This JMS client can be segregated in 2 types. For senders, producers and publishers are senders, and there are 2 other types of JMS clients which are receivers, consumers and subscriber. And the JMS application is composed of many JMS clients and a JMS provider. So combination of JMS clients and provider creates a JMS application system. If you want to represent it pictorially, this is me and this is my friend, and this is somebody else as well, right? So this is JMS client is a producer of the information, this JMS client is consumer of the information, and this JMS client is both producer as well as consumer of the information. So it can send as well as receive, and this is JMS provider, right? The post office, the postman, which actually via which the whole delivery things happen, which guarantees the delivery once and only once, and guarantees for sure that it will definitely be delivered. Right, so this is how a JMS application looks like, and there are message oriented middleware. There are various examples. I've just picked a few. Some of them are WebLogic, MQ series, JBoss, Sonic MQ, TIBCO EMS, and we will be mainly looking at this Active MQ. So this is how the Active MQ look like. It's from Apache. Of course it's free. You have the source code available itself, and I'm using version 5.4.3 of it. We'll have a quick demo of how this Active MQ runs and how it looks like and how to set it up and how to download it in later slides. There are 2 types of JMS models, point to point and publish subscribe. In publish subscribe there are 2 types further: durable, persistent, and non-persistent, non-durable. For durability you need to have database in between to save all the publish subscriber message. In non-durable it can directly be delivered whoever is available in the system. In point to point, it is built around queues based on the principle first in first out. Whoever is first in the queue will get the services first, whoever is last in the queue will get the services last. Each message has only one consumer, and in publish subscribe each message has multiple consumer. Let's see it pictorially. That there is a sender, this is the queue, say for example Active MQ, MOM, and this message which is being sent will be received by one of the receiver. If you want to see it further, the varieties of it, that it does not mean that you have to have one receiver. I mean, multiple receivers can be configured, but it will only be received by the one receiver. So you can have one sender and one receiver, producer and consumer. A JMS queue, a message will be received by a receiver. You can have multiple senders and one receiver. All the messages that is being sent will be received by this receiver, or you can have a single sender and multiple receiver, but it does not mean that one message will be received by all 3 consumers. This is the most important aspect, that if it is sending first message for receiver 1, second message for receiver 2, and third message for receiver 3, first message cannot be delivered to more than one receiver. That's the important bit, and that's why it is represented like this and this. The important point is queue might have more than one sender and more than one receiver, but only one receiver may consume each message. That's the basic fundamental of point to point. And if you want to further pictorially understand it, you can have multiple applications sending the message over a queue, and this application is consuming both the sender's message. Sends, receives, and acknowledges. These are the three important functions and behaviors of point to point model. Sends, consumes or receives, and then acknowledgement happens as well to ensure the reliability of message, that message has been consumed properly. And there is no acknowledgement, it will assume that the message has not been received, has not been sent. There are various algorithms which ensures the reliability of delivery of message. That's how the point to point look like. The fundamental is only one receiver may consume each message. Let's quickly look the publish and subscribe. In publish and subscribe, instead of queue we have topic. Publisher sends a message, topic replicates the message into as many subscribers as we have, so it creates copy of a single message. It creates 3 copies of the single message and it delivers to all 3 subscribers. It's like a newsletter, right? A single newsletter is delivered to everyone, but if I am writing a mail to my friend, only that friend is intended to receive it. So me sending a mail to my friend is point to point, and me sending a newsletter or a pamphlet or a newspaper delivering message to everyone is publish subscribe model. So in this, what happens is you can have a single publisher and multiple subscriber. So each message will be published to a topic, and then that topic will deliver it to multiple subscriber. It also can be translated in this way, that there can be multiple publisher and multiple subscriber. So each of this guy will receive everyone's messages, right? This message published to a topic is broadcast to all clients that subscriber to this topic. Very easy concept. In this, what happens is client A publishes, topic receives it, it delivers it, client 2 subscribe it, then it is delivered, client 3 subscribes to the topic, then it is delivered. So subscribes, delivers, subscribed. Same thing, you can have multiple publisher, you can have multiple subscriber. That's how we describe the point to point and publish subscribe models. So what are the differences between these two? Each message has only one consumer. This is the focal point of P2P. Each message has multiple consumer. Message queue are first sent to destination named queue, and message are first published to destination called topic. So queue versus topic. A sender and receiver of a message have no timing dependencies. The receiver can fetch the message whether it is not running on the whether it was not running when the client it simply means that it can work in synchronous as well as asynchronous way. And publisher and subscriber have a timing dependency. Client that subscribes to a topic can consume only message published after the message has been created for the subscriber. Receiver acknowledges the successful message of processing, and in publish subscribe model the acknowledgement is not needed. How does the JMS API programming model look like? Of course, it will be similar as any other. In the database model itself, what we have, we first create the connection. After creating the connection, we create we first create the driver connection, and then we fire the SQL, get the result set, and process the result set. That's the standard database thing. Similar thing happens. We create the connection. Connection gives you a session. Session creates either a producer or a consumer, and producer will send a message, consumer will receive a message. That's a typical JMS API programming model. So you always need to remember this sequence in the JMS world, that you have a factory, you have a connection, then you get a session. From session you get either producer and consumer. If it is producer, it will send it. If it is a consumer, it will receive it. And code perspective, how it looks like, of course, you first create factory, connection, session. So you create connection factory, connection from the factory. Don't worry about the context part, I'll get into it in details later on. So you get the connection factory, you get the connection, and then you get a session from that. And from session you can get if it is a point to point model, you will get a queue, and if it is publish subscribe model, you will get a topic. And within this, you can have, within topics you can have the producer and consumer, and within topic as well you can have producer and consumer. The responsibility of that queue or dot topic will be either to send or to receive. So that's JMS client. That's how a JMS client looks like. Let's see how the producer looks like. Of course, we'll set up the connection and create the session. So there we saw that we create the session from the connection. You create a session and then you say I want producer. From session you are getting a producer. So you're getting a producer of what? Of that topic or the queue which you have just created here. So either 1 or 2 based on this topic or queue. You're saying that this topic and whatever I produce will be sent to this queue, and I'm creating a producer, and I'll use this producer. I'll create a message, set some data in it. It can be a simple text file, it can be an XML, it can be a complete SOAP message, it can be a complete brand new type of envelope. So we send the message, and then I'll say producer.send. Then I'll say producer.send, and then finally we close the connection. You create the connection and a session. From session you create a consumer, and you say destination. What are you trying to consume? Are you trying to consume a queue or a topic? So you create the consumer, you start the connection, and you just sit and receive the data that is being sent by this producer. In the previous slide, producer.send and consumer.receive. So there are two ways. What we are doing is, there are two ways of generating the consumer. What we are doing when we say receive, it is synchronous. The other way is asynchronous. Synchronous simply means that waits for a server to respond. So if one end is down, entire communication will fail. Asynchronous messaging involves a client that does not wait for a message to. Say if I sent a message in the morning, and if it is a synchronous message at 6:30, the receiving end should be up and running at 6:30 in the morning. But if it is asynchronous, if I send a message at 6:30 in the morning, and if the receiver's message is down, service is down, system is down, it won't receive it. But if he comes at 9:30 or later in the day, in the evening, he'll still receive it. That's the way asynchronous can be defined. So this way we are simply defining the synchronous model. If you have to define the asynchronous model, the difference is that we do a listener in this case. So we set up the connection, create the session, create the consumer, and then we register a listener to the consumer. Set message listener, we register a listener to the message consumer, and my listener should have on message method. So in this listener you need to have on message method, and this message method will read the message and do the computation based on the message received. So again the same logic: factory, connection, session to consumer, and consumer to receive. So on message is what? Nothing but asynchronous form of receive. Synchronous consumer is consumer.receive. Asynchronous consumer is listener with on message method. That's how it looks like. Now we have understood the basics of JMS. What are the different components of JMS, what are the different models, point to point, and so publish subscribe. Let's see where JMS comes in between. So JMS provides JMS integration framework. This simplifies the use of, in a typical code, what you have to do. In a typical code, you do this, you do this, you do this, you do this. Instead of doing this is a template code. You always do this. Why not write a single thing? Why not write a single thing called JMS template? This JMS template will do all the basic stuff for you. You won't have to write all these piece of codes every time. So here you see that facilitates the JMS API similar to JDBC API. You have JDBC template as you have seen before. Here you have JMS template. A JMS template class is used for message production and synchronous message reception. So synchronous message reception similar to Java EE. In Java Enterprise Edition we have the EJB MDB, message driven bean. So instead of message driven bean, Spring provides message driven POJOs. So message driven POJOs already have the on message implementation is already a ready-made build message listener container, and we simply use the message. We'll see in the example that how MDPs work. Instead of message driven bean, EJB's message driven bean, it is replaced by message driven POJOs. So let's begin with some of the JMS integration part with framework. JMS provides this namespace and JMS provides this XSD. You have this framework jar that is available, dependency that is available. If you download ActiveMQ, you will get this jar as well. So that needs to be in your class path, and this is the link. You can go there and you can download it. Let's quickly run through the demo of it. So in demo, first we will have a quick look at core Java non-Spring application demo. Within this we have a consumer and we have a producer. For consumer and producer to work, what I'll do is I'll simply run the ActiveMQ. To run the ActiveMQ, I'll just go through the this is the jar that you download and you explode it here, and this ActiveMQ, you go in there and there is a bin. In this bin you just double click on it. I've just created a shortcut of this here in my training session area. So ActiveMQ shortcut, I'll just double click on it. This will start the ActiveMQ, right? So once it is run, admin is available at this location, and there are some demos which is available at this location, localhost 8161 admin. You see 8161 is the port where the ActiveMQ is hosted. So this is the ActiveMQ, that is what it will look like. So if you go and see, I'll just delete all the queues that is created here. I'll clean up everything and all the topics. I'll just go to do some demo. In the demo they have provided send a message and receive a message. So for example, test active MQ queue. This is the queue name that I've provided, and I'm saying it is a queue, not a topic. And I'll say active MQ test. I'm just producing the message, right? So it is just for sending a message. I'm just sending it. I just said sent, right? Let me quickly see if something has happened. See what we did? We had this text ActiveMQ, that queue is created here, and we have said ActiveMQ test. So this message has two messages that has been sent to it. It is showing into the number of pending messages because it has not been consumed. No consumer has connected to it. It has not been dequeued. So I'll quickly look into inside these messages. So there are two messages. First message is having a text ActiveMQ test, and the second message is also having a ActiveMQ test. For the same message, I'll say ActiveMQ message test 3 and I'll say send. Let me quickly go back to queues. Now you can see there are 3 entries here, ActiveMQ 3. The third one, they should say 3. Very simple. And same applies for the topics as well. Instead of this, I'll say topic test topic 1. Yeah, so I'll go and say topics. See, test ActiveMQ topic. There is a number of one message in queued. Within this one message, you will see that there are some content in it. So because there is no subscriber, so nobody has received it. So we have a producer. Producer is very simple. We have already discussed that. What is the sequence that we are supposed to follow? The sequence has to be connection factory, connection, session, message producer, consumer, send and receive. So connection factory, connection, session, create a queue, and that queue will be creating a producer or consumer. You will pass the producer or consumer, and this producer will say producer.send. Very straightforward. Within consumer, same story, connection factory, connection, session, then you create a queue, you pass that queue inside the to create a consumer, then your consumer, and you say receive. Producer creates a producer on the session and sends the message. Consumer creates the consumer on the session associated to a queue or a topic and receives the message. So consumer receives the message, it is created on top of session, and producer sends a message, it is created on top of session, and both need which queue to send to and which queue to send from. So let's quickly see the details of it. So we are using ActiveMQ API because we have already put the jar here apart from the Spring 3 dependencies where we have the JMS jar. What we are saying here is that okay, my producer is, we have already had we can have an import ActiveMQ factory, and you are just passing the path. So you can see it here. So I have put it in here to get the connection factory, and now I'm saying connection factory dot create connection, starting the connection. I'm saying connection create session, it will auto do the acknowledgement. There are various ways of acknowledgement, we'll see in details later on. So I'll just take the default one, and session is created, session dot create queue. I'm saying new queue. Yeah, so hello world dot test queue is the new queue that I'm creating, and I'm saying okay, the session dot create producer on which, on this destination, and I'm delivery mode non-persistent. I don't want a database specific persistence, and I'm saying this is the message text hello world from, I'm creating the associating the thread name to it, text message dot text message, and finally sys out. And before sending I'm saying that message sent, and producer session close, connection close. Consumer same thing, the only difference is that it will be creating a consumer instead of producer here, and it will be receiving the message. It will wait for that message to appear on the queue for 1 second. If it is instance of text message, it will receive, and if it is not, it will simply receive the message, consumer close, session close, and connection close. Let's quickly run this application and see how it behaves. So within JMS app, what we are doing, we are simply saying main execute. We are creating the consumer.main to run first, which will put the queue on the MQ queue. We'll keep observing the queues as well here. At the moment we only have foobar and test active MQ queue. Let's quickly run the application and we'll see that a new queue is created, a queue is placed there. Producer will execute first. Producer will say sent a message, right? So sent a message this, and it will reach the MQ queue. See, a test queue has come in. So one message was enqueued and it was dequeued as well because my receiver, my consumer received it. So it will go to consumer, consumer will connect to same queue and it will consume it and receive the message. That's what you can see here. The one message was enqueued and one message was consumed. Very simple application. This application can be translated into threads as well, where we can create a hello consumer thread. The same application, no difference it is. The only thing is that we are creating a thread instead of main method. We are saying it is a runnable, and in the main method we are saying that it is a runnable set daemon and thread start. So in this way we can have multiple consumers and multiple producers. So you can say how many producers we have, 1 2 3 4 5, and how many consumers we have, 6. So I'll simply run it, Java application. So how many sent messages, because there are 6 producers, 6 sent messages and 6 received messages. Because a thread, these are thread, so sequence doesn't matter. Even though after 4 producer we have a consumer, but all the producers were executed first and receiver were executed, it doesn't matter, it can be anything randomly. So if I see here, I should see many messages on the hello world test queue. What happens? 30 message enqueued and only 9 message dequeued. Why? Because I tried it twice and 2 messages were extra, because we are sending 6 and receiving only 4, so 2 message left on the queue itself, nobody received it, and because we have hit this application twice, so 4 messages kept lying on the queue. So 13 were sent and only 9 was dequeued. 1 was here and 6 plus 6 here, so that's why it is 13. And if I want to see the content of it, I can simply go here and I can simply see hello world from thread. This is nothing but the producer content here. This is core JMS. This has nothing to do with Spring JMS. Spring JMS looks like this. Here we say two beans, connection factory and the JMS template. Everything is done here, and in the code how much you do? You simply say XML, you get the JMS template, and I have just run this loop for 10 times. It is not necessary to run it for the 10th time. I'll simply say this one to avoid any confusion, and I'll say template.send. You don't have to follow the sequence that you first have to create factory, connection, session, producer or consumer, and send and receive. You get everything. You just say this is the thing and this is the template. So you say template, everything is managed in the XML itself. This is your connection, and within this is your connection factory, this and this. In the code you are simply saying that template and send. Within send, this is the whole method. There are two parameters, which queue you are sending to and what message you are sending to. So send a message, we have just created a new creator, and within new creator we have done a create message, and we are just creating a random message itself. If we run it, the JMS template will be created, connection will be made. On this queue, this message will be sent across, but we are not receiving. Remember, we are just sending, we are not receiving the message. So I would expect this message lying on this new Spring send test queue, Spring send test queue, and one message is lying, and the message has a Spring test queue. So you can play around this code. You can add a basic code to receive the message that you have sent across, but I'll quickly move on to the next part, which has this quite interesting JMS chat application, in which what we have is it's a real life implementation of messaging system, where we have a basic JMS chat and we have the basic Spring config XML, where you have the connection factory, and because it's a chat, it's a publish subscribe model, so we need to have a topic. So I am creating a topic called chat topic, and I am using AMQ, which is ActiveMQ tag library, and AMQ we create the JMS template, and we are creating a basic JMS chat bean. This is the bean that we are creating, and we are adding a listener, the default listener. That's the listener we talked about here in the slides, where we said, okay, this is the listener, a synchronous message. The first one was synchronous, send and receive, but we are saying we are having a listener, and JMS provides message driven POJOs instead of EJB MDB, message driven bean. Now we are using MDP. So this is the example of MDP. In this MDP, we need to provide what is the connection factory, we need to provide what is the topic that we are talking on, we need to provide the message listener that we are already creating here, and concurrent number of consumers. So let's quickly delve into the basic JMS chat. In this JMS chat, we can see we are injecting the template, we are injecting the topic, and we are injecting the user ID. We'll tell you why. In this main method, what we are doing is we are creating the application context, the straightforward Spring application context. We are getting the basic JMS chat, this class itself, from the basic JMS chat, and we are creating. I have kept this verbose just for the sake of clarity, rather than directly doing a send and receive from the template, just to make sure that we all understand this. So don't worry about it. You can skip some of the verbosity that I have added here. From this template, you are getting the connection factory, and on this connection factory you are creating a topic connection, and then you have publish method and you have a subscribe method. So publish will do what? Publish will, TC is what? TC is your connection, topic connection, and then you are passing the topic, the topic where message is being sent and received, and the user ID. So in publish you are passing these three things. So what it will do? From connection it will create a session, from session it will create a publisher. The same logic, factory, connection, session, producer, consumer, send and receive. So publisher, subscriber, send and receive. So publisher is what? Producer. Create producer, connection start, and now we are saying user to enter something. So we are using buffer reader, input stream reader, system.in. Whatever user enters, we are reading in this line. If user clicks on exit, we'll close the whole system, but if user enters something, whatever user enters, we'll publish it. Now that is publish part. I'm asking user to enter something, and I'm publishing that text. Subscribe will say, okay, this session on this queue itself everyone is subscribing, and I'll say create subscriber, and I'll simply say who is the subscriber. This class itself, because it is implementing listener, it is the subscriber. So it will receive the message, and because it has a it is a listener, so this listener has to implement on message method. So on message, once it receives something, because it is subscribing, the moment something publishing will happen, subscriber will receive it, and on message of the listener will be executed. So what will happen? The moment something is put onto the topic and we receive it, on message will be called, and message, if it is instance of text message, what we are doing is we are simply outputting whatever is received from it. In the XML, connection factory and topic, you define the JMS template, and in the basic JMS template, the class that we are creating here, you are injecting JMS template and the queue, that is to topic, and listener you are providing the connection factory, destination, the message listener, and the concurrent consumer. To run this, we have made sure that while running this, user provides a user ID, and that's the reason we have written this piece of code, that if user ID is not there, you need to redisplay it. Otherwise, whatever is user entering, I'll treat that as user ID. So it will be easier if we run it as a from the command line, because it's a chat system, publish subscribe model, so I will have to have more than one client to demonstrate it to you. So what I'll do is I'll export it as a runnable jar, and I'll say next, and I'll say at this location what is the basic class that I want to run, basic JMS chat, and I'll give the jar name as this, extract required libraries into the generator jar. I'll say, so jar has been created with some warning, so don't worry about it. And if I go to the application, I can see this jar is created here. So what I'll do is I'll quickly run the command prompt, and I'll say I'll run the jar. How to run the jar? Java dash jar spring, and because it requires a R parameter, I'll say user1. So this should run the application. Here's the first application. So it is running the application, loading my spring config com spring training /jms chat com spring training spring config, and it has started it. So I can type in something, hi, hello. So this is being reverted back to me. If I run it again, java dash jar spring chat, and then say Rahul. Now we have two applications sitting side by side. Now I am typing things here, hi. See, Rahul has said hi, and it is being displayed here. I'm saying Amar will say hello, this is being displayed here. What I'll do is I'll use a third one, which is simply be a consumer, it won't be a publisher. So I'll say java dash jar, I'll say spring chat, and then I'll say Priya. Yeah, so we have this, we have this, and we have this. So Amar say how are you, this is broadcasted at both the places. How are you? See, it is being broadcasted here. We can do some further clean up, and we can just whatever echo is happening, we can reduce that as well. But this is the basic publish subscribe model. In this case, this user Priya is just a subscribe. It can convert itself into model in the subscriber as well. So you can say Priya here there, and this is the whole chat system. So we'll dig deeper into this system, and we'll try to improve upon it as a project. But that's how the publish subscribe model looks like. So in this session we have covered the basics of JMS, and we have covered a little bit of programming model, and we have covered some of the demos that we have seen. So we have demoed MQ, we have demoed the basic asynchronous model using send and receive, producer and consumer, with main method and with thread. Here we have seen the spring specific JMS template, where we have seen the example of send and only, and then we have seen Spring JMS chat application. So in the next video we'll try to see the details of it and the miscellaneous topics that needs to be covered in this topic. See you there.